Okay, so today we're going to use one of the handouts that was linked on the distance learning calendar that wasn't printed in your student note packet. So you guys need to find the Angle Families handout, which is on the back of the unit circle. Hopefully you guys printed that out or have a digital copy of that. And then we'll get to the student note packet. We're going to be looking at page 7 in the student note packet, which is section 6.3, Trig Intro, day 2. So today you need a calculator, your student note packet, and then the unit circle handout that's linked on the distance learning calendar. We're going to find the page that says Angle Families, and we're going to trace the angle families today. We're not going to actually get to the front, which is the unit circle, until another lecture. But we are going to talk about the angles on the unit circle that are really important. So the first angle we're going to look at is the 0-degree angle family. Now remember that the unit circle is a circle with a radius of 1. So every time I mark a radius of 1, we're going to include that in our measurements. All right, so imagine that I centered that perfectly. But the first angle in the 0-degree angle family is 0 degrees, which is 0 radians. And if I were to create a point on the unit circle at 0 degrees and extend a ray to create that angle, right, that's what it would look like. And this ordered pair here would be 1, 0 if our point is on the unit circle with a radius of 1. Now the next angle on the unit circle in the 0-degree angle family is 90 degrees or pi over 2 radians. Now again, if I'm going to mark the ordered pair that represents 90 degrees, that's going to be 0, 1 because it's sitting on the positive y-axis. All right, our next angle in the 0-degree angle family is 180 degrees. That is pi radians. The ordered pair there would be negative 1, 0. It's sitting on the negative x-axis. And then the last angle that we draw here is going to be sitting on the negative y-axis. That is 270 degrees or 3 pi over 2 radians. And that's represented with the ordered pair 0, negative 1. It sits on the negative y-axis. Now technically this angle back here is then also 360 or 2 pi radians, but when we express answers fully simplified, we're going to use 0 degrees. 0 and 360 are what we call coterminal angles. They end at the same place, but 0 is going to be the simplified answer. All right, so next up is the 45-degree angle family. Still on the unit circle, so still on a circle with a radius of 1. I'm going to graph my first angle in the 45-degree angle family. That is 45 degrees. It's the angle that goes directly through the first quadrant. Now I'm going to mark the point that sits on the unit circle there. And what I'm going to do in order to figure out what that ordered pair is I'm going to create a right triangle by dropping a perpendicular down to the x-axis like that. And I'm going to drag that triangle outside of this unit circle, make it a little bit bigger so I can show more work here. But if this is my angle, and it's 45 degrees, and I purposefully created a right triangle, that means that this angle up here is also 45 degrees. Okay, what else we know? Well, we know that the hypotenuse must be 1, since that's the radius of our unit circle. And now we can use special right triangles, the properties of special right triangles from geometry, in order to figure out what the x and the y coordinates are to get us to that ordered pair. So remember that the relationship between the sides of a 45, 45, 90-degree triangle are x, x, x root 2. So starting with the hypotenuse going backwards, we're just going to be dividing the hypotenuse by the square root of 2. And then we'll always make sure that we rationalize, because we never want to leave a radical in the denominator. So that leaves us with the ordered pair, root 2 over 2 here, for both the x and y coordinates. All right, now that was 45 degrees. Remember that 45 degrees is pi over 4 radians. Okay, so moving around the unit circle, next, if I go another 45 degrees, I am sitting up here on the positive y-axis. Now, that's already part of the 0-degree angle family, so we don't include that in the 45-degree angle family. So my next 45 degrees is going to be over here in the second quadrant, and that is at 135 degrees, or 3 pi's over 4. And the ordered pair here is going to have a negative value for x, still the same positive value for y. Okay, moving another 45 degrees, we are now at the negative x-axis. We've already got that angle marked in our 0-degree angle family, so I'm not going to worry about including that in the 45-degree angle family. So I'm going to move another 45 degrees, and I get down here to this angle in the third quadrant. That is 225 degrees, or 5 pi over 4. And this ordered pair is going to have both a negative x and a negative y because we are in the third quadrant. Moving another 45 degrees puts me on the negative y-axis. Same thing, that is an angle that's already marked in the 0-degree angle family. So the last thing that's left to do, go one more 45 degrees, and we get down here to an angle in the fourth quadrant. That is 315 degrees, or 7 pi over 4. And in the fourth quadrant, the x values are positive, but the y values are negative. All right, and then that puts us back to 360 degrees or 2 pi radians, which again, already on the 0-degree angle family. So there's our 45-degree angle family. All right, next up, we're gonna do the 60-degree angle family. So the first angle I'm gonna draw is 60 degrees. That's a little bit more than halfway through the first quadrant. Now I want to identify the ordered pair that sits out here on the unit circle. So I'm going to do the same thing I did with the 45-degree angle family. I'm going to drop a perpendicular to the x-axis, and then I'm going to work with that right triangle in order to identify the x and y values to get us to that ordered pair. So if this is a right triangle and that angle down at the bottom is 60 degrees, that makes this a 30, 60, 90. Again, the hypotenuse here is 1 because the unit circle has a radius of 1. And we're looking for the values of x and y. Now again, this is a special right triangle. We just have to remember the relationship between the side lengths of a 30, 60, 90. So with the 30, 60, 90, it's going to be x root 3, and then 2x. So going backwards, starting with the hypotenuse, the short side is always the hypotenuse divided by 2. So in this case, our short side is x because it's the side opposite the smaller angle. And then we take that short side, 1/2, and we multiply it by the square root of 3 in order to get the longer side. So y here is the square root of 3 over 2. So our ordered pair then is 1/2 root 3 over 2. That angle is 30 degrees, and that is pi over 3 radians. Okay, now I'm going to go another 60 degrees. Another 60 degrees is going to get us to 120 degrees, or 2 pi's over 3. And this is in the second quadrant. So remember, in the second quadrant, our x values are negative, our y values are positive. So negative 1/2 root 3 over 2. If I go another 60 degrees, we're down here on the negative x-axis. Already got an angle there in the 0-degree angle family. So I'm going to move another 60 degrees. That gets me to this angle down here in the third quadrant. And that is going to be 240 degrees, or 4 pi's over 3. And in the third quadrant, both x and y are negative. So negative 1/2, negative root 3 over 2. And then one more angle here, going to move another 60 degrees. That gets me to the fourth quadrant. This angle here is going to be 300, or 5 pi's over 3. And in the fourth quadrant, the x value is positive, the y value is negative. So positive 1/2, negative root 3 over 2. And then our final 60 degrees would get us back to 0. Last angle family then is 30 degrees. Okay, so 30 degrees, smallest angle here. I'm going to draw a 30-degree angle first. That puts me in the first quadrant. I'm going to find the point that sits on the unit circle. I'm going to do that by dropping a perpendicular to the x-axis and then pulling this special right triangle out to kind of show work here. So this is a 90-degree angle. This is the 30-degree angle, which makes the other angle in this triangle 60 degrees. Now I'm going to do the same thing we did with the 60-degree angle family. The short side then is 1/2. It's the hypotenuse divided by 2. The long side is going to be the short side times the square root of 3. So our ordered pair here is the square root of 3 over 2, 1/2. We just swapped the x and y values from the 60-degree angle family. All right, if I go another 30 degrees, remember 30 degrees is pi over 6 radians. If I go another 30 degrees, that actually gets us to the 60-degree angles family, so we skip that angle. Another 30 degrees would put us on the positive y-axis. We've already got that angle. Another 30 degrees gets us to 120 degrees, which we've already got from the 60-degree angle family. So all that's left over here in our second quadrant is 150 degrees, or 5 pi's over 6. Now, in the second quadrant, x values are negative and y values are positive. All right, those two lines are a little bit lopsided there. One more set of 30 takes us to the negative x-axis. We're already there on the 0-degree angle family. So then I move another 30 and I get down here. Third quadrant. In the third quadrant, both x and y are negative. So negative root 3 over 2, negative 1/2. This angle is 210 degrees, or 7 pi's over 6. Okay, another 30 would get us to an angle on the 60-degree family. Another 30 would get us to the negative y-axis. Another 30 gets us to 300, which is part of the 60-degree angle family. So the last 30-degree angle is going to be here in the fourth quadrant. Remember, fourth quadrant, x values are positive, y values are negative. This is 330, or 11 pi's over 6. Okay, so later on, we will then take all these angles and we will put them on the front on the unit circle. Okay, so now we're looking at page 7 of the student note packet. I'm going to start at the bottom. You guys are going to finish up 14, 15, and 16, but I'm going to demo 13 for you guys. This is kind of the opposite of what we were looking at on page 4 in the last lecture. So we still have a table. We want to find all 6 trig functions, but instead of giving an ordered pair like I did in page 4, I'm giving you guys an angle now. So we want to graph this angle, 300 degrees. That's the first thing that we're going to do here. So where is 300 degrees? Well, 300 degrees is sitting over in the fourth quadrant. So that looks something like this, and I'm just going to sketch, relatively accurately, something like that. And then I'm going to drop a perpendicular to the x-axis here and kind of fill in what I know about this triangle that I just created. So this is a 30, 60, 90. And if we're dealing with unit circle, we're going to assume the radius here is 1. That makes the short side 1/2 and the long side root 3 over 2. Now, because we're in the fourth quadrant, that y value is going to be negative. And then we can go about finding all of the 6 trig functions. So sine here is opposite over hypotenuse. So in this case, the hypotenuse is 1, so just negative root 3 over 2. Cosine is 1/2. And then tangent is going to be negative root 3 over 2 over 1/2, which is just negative root 3. Cosecant is the reciprocal of sine. Right, negative 2 over root 3, but we are going to rationalize. So when I rationalize, we get negative 2 root 3 over 3. Secant is the reciprocal of cosine, so that's 2. And then cotan is going to be 1/2 over negative root 3 over 2, which is negative 1 over root 3. Or you could have taken the reciprocal of tangent. Now I have to rationalize that. That is negative root 3 over 3. Okay, so draw the diagrams for 14, 15, 16. You can do it right next to the angles on page 7. But we're going to go to the top now of page 7 and take a look at the last few examples. Okay, so at the top of page 7 of your student note packet, we have these examples. I'm going to do 1 through 6 with you, and then you'll do 7 through 12 and check your work. You do need a calculator, and then you're going to do the homework problems from the textbook the same way that we're going to do these problems in lecture. So you're going to type everything into the calculator. We're going to write what we type into the calculator, and then we're going to draw a diagram to represent that value that we get. So tangent of 47 degrees, the first thing that's really important is that your calculator is in the correct mode. So whatever calculator you're using, graphing or scientific, hit the mode button and just make sure degrees are being is what's being highlighted there. Otherwise, you're going to get the wrong answer. So for number 1, we're just going to type in the tangent of 47. I don't need to worry about writing that out because number 1, the problem is already the tangent of 47. And what we get when I type this into the calculator is 1.07. So make sure you guys are getting the correct answer. If you didn't get 1.07, it might be because your mode is off. Now here's what I mean by drawing a diagram along with what's written or typed into the calculator. The tangent of 47 degrees. Okay, so here's what I'm going to do. I'm going to draw an angle that represents 47 degrees. Right, that's 47 degrees. And we are told that the tangent of this angle is 1.07. So what would make tangent 1.07? Remember, tangent we define as y over x. So if the y coordinate is 1.07 and the x coordinate is 1, we get an angle, 47 degrees, that gives us a tangent of 1.07. All right, so this would not be on the unit circle because the hypotenuse here isn't 1, but this is a diagram that represents the situation. So you guys are going to draw a diagram for each of these problems. Okay, the sine of 339. Again, I'm not going to type, or I don't need to write anything out there. That's what we're just typing straight into the calculator. When I calculate this, we get negative 0.358. And now I'm going to draw a diagram. So 339 degrees, somewhere down here in the 4th quadrant. I'm going to drop a perpendicular and draw a triangle here. Now sine is always y over r. So what would make the sine of this angle negative 0.358? Well, if the y value here was negative 0.358, and if the hypotenuse was 1. So this would be on the unit circle, right? We have a radius of 1 here. This would just be the point whose y-coordinate is negative 0.358. All right, number 3 is where it gets a little bit more complicated. So remember that secant is the reciprocal of cosine. So when I type this into my calculator, I am going to type in 1 divided by the cosine of 144 degrees. So that's what's important, is just making sure that you guys are getting the right values, that you're typing things into your calculator correctly. And we get negative 1.236. So again, what kind of diagram would give me this value, would represent a secant of 144 degrees equaling negative 1.236? Well, let's start by drawing 144 degrees. 144 degrees is somewhere over here in the 2nd quadrant. I'm going to drop a perpendicular, right, to draw a little triangle here. And secant is the reciprocal of cosine. So secant is going to be r over x here. So what would make secant of 144 degrees equal to negative 1.236? Well, if our value of r was 1.236 and our x value was negative 1, that would work. We will never make r negative because the hypotenuse of our triangles comes from taking the square root of x squared plus y squared. So that will never be negative. That's why the 1 has to be negative there. And it's also in the 2nd quadrant, so that makes sense. It aligns with the signs that we need. Number 4, we're taking the cotan of 683 degrees. So again, we're going to do cotan like we did secant. Cotan is the reciprocal of tangent. So in my calculator, I am typing in 1 divided by the tangent of 683 degrees. And we get negative 1.327. All right, I'm going to draw this diagram now. 683 degrees. If we think about that, that's obviously greater than 1 full rotation. 683 degrees is 360 plus 323. So I'm going to go around the circle 1 full rotation, and then I'm going to go around another 323 degrees. So that's going to put me somewhere over here in the 4th quadrant like that. Okay, and if I were to draw the squigglies, we would go 1 full rotation plus another 323 degrees. All right, still going to draw my perpendicular to the x-axis and draw this diagram. What would give us a cotangent here? That's negative 1.327. Well, remember that we define cotangent as x over y. It's the reciprocal of tangent. So in this case, the y value is what has to be negative. So this is going to be negative 1, and the x value is going to be positive 1.327. We're in the 4th quadrant with our angle, which means y values in the 4th quadrant have to be what's negative. The positive value needs to be the x value. The cosine of 222 degrees, type that into your calculator. You should be getting the cosine of 222, negative 0.743. All right, 222 degrees. It's down here in the 3rd quadrant. I'm going to drop my perpendicular to the x-axis. Now, what values can I include here to make this negative 0.74? Well, in the 4th quadrant, the x value here is negative. And cosine is x over r. R is going to be positive 1. R is always positive. All right, last one, cosecant here. Cosecant of 4 degrees. So I'm going to type in 1 over the sine of 4 degrees because cosecant is the reciprocal of sine. I don't know if any calculator has cosecant, secant, and cotan buttons. If your calculator does, that's great. If not, we'll just use these reciprocal functions here by doing 1 over cosine, sine, or tangent. So in this case, we should be getting 14.34. Or 336. Okay, I'm going to draw the last diagram here. 4 degrees is really small in the 1st quadrant. Okay, and sine is y over r, which makes cosecant r over y. So here in this case, r is going to be 14.336. And the y-coordinate is going to be 1. All right, give that a try for 7, 8, 9, 10, 11, and 12. For numbers 7, 8, 9, 10, 11, 12, you guys are going to make sure to turn your calculators into radians because we're not dealing with degrees for those problems. Get the values and then draw the diagrams. So on the next slide, go ahead and pause the video now. I will put the answers to what you should be getting in your calculator up. Your diagrams you're going to draw on your own. Okay, so 7, 8, 9, 10, 11, 12, all in radians here. Answers on the calculator should look like this. All right, email me if you've got questions on that, you guys. You're going to do the bookwork the same way we did the lecture. So for 63 to 74, you're going to write what you type into the calculator, and 45 through 62, you're going to make sure you draw the diagrams and then find the trig functions there.